Hello students. In the previous lecture, we have already learned how to solve functions wherein we have to convert them into logarithmic functions and then find their derivatives. In this lecture also, we are going to do the same thing, and these sums which we are going to discuss today are going to come for you for a minimum of 3 to 4 marks at least. So concentrate, understand properly so that you are able to recall these sums later on. Now these are some of the laws which we had used in our previous lecture. The same laws that we are going to use over here in this lecture as well. So just go through them for half a minute before we go further. In the exercise, the question is going to be the same, that is find dy by dx. The first question, y is equal to log x raised to x plus x raised to log x. Y is the sum of two terms and both the terms are complex terms. So we go further by writing let u is equal to the first term log x raised to x and v be the second term, that is x raised to log x. Thus y becomes the sum of two terms u plus v. When we differentiate both the sides with respect to x, we get dy by dx is equal to du by dx plus dv by dx. Let that be the first statement. Now, we have to differentiate both the terms u and v individually and find their differentiation. Thus, u is log x raised to x. Now, such functions we know that it becomes easier if we take logarithm on both the sides and then differentiate. So, we take logarithm of both the sides. We get log u is equal to log of the log of x raised to x. Again, you remember that from the last lecture. When there is a logarithm, the power of the logarithm can be written as a product of the power and the logarithm. That means it is one and the same. So we get this way, that is log u is equal to x into log of x. Now we differentiate both the sides with respect to x, and thus the LHS becomes 1 upon u du by dx. Of course, you will remember that it is u and not x on the LHS. Log of any function, when we differentiate, it is 1 upon. So log of u is 1 upon u, of course. But since we are differentiating with respect to x, we get by chain rule du by dx as well. So LHS is 1 upon u du by dx. On the RHS, the product rule, that is x into differentiation of log x plus log x, the differentiation of x. Now we find that log x, that is, it's a composite function. When we differentiate a composite function, we use a chain rule. You'll remember what is a chain rule, isn't it? So we proceed this way, that is the LHS remains the same. But in the RHS, x into the ddx of log x is 1 upon log x. And by chain rule, we also have to find the differentiation of the inner bracket, that is log x, plus the next term, that is log x into the differentiation of x is 1. And the next step, that is on the RHS, we simplify and write x upon log x into the differentiation of log x in the bracket we have written in the previous term is actually 1 upon x. So that is coming over here, plus log x as the second term. Now since x is common, of course we cancel it and we get our answer as 1 upon u du by dx is equal to 1 upon log x plus log x. Now u comes on the RHS. You will remember from the last lecture that we need only du by dx on the LHS. So the u term comes on the RHS. So now what remains is that finding the final answer for du by dx at least. So du by dx is equal to u was log x raised to x. So we write the u term over here and the remaining part of the sum remains the same. Let that be our second statement now. Then we also have the other term, isn't it? V is equal to x raised to log x. Again we take logarithm of both sides. We get log v is equal to log x raised to log x. Next step, of course, the log x, which was the power, is written as a product of the log x. So we get log x into log x on the RHS. Then thus we can write log v is equal to log x the whole square. Now when we differentiate both the sides with respect to x, log v becomes 1 upon v dv by dx, and on the RHS again we are using the composite rule. Differentiation of a composite function. The outside inside rule, students remember, or the chain rule, wherein first the square term is differentiated. The differentiation of the bracket square is 2 into the bracket. So the differentiation of log x the whole square is 2 into log x. Also by chain rule, the differentiation of log x once again, because you remember that it is not x in the bracket but it is log x. So we find the differentiation of log x as well. Thus in the next step, the RHS becomes 2 log x upon x by finding the derivative of log x. Then in the next step, dv by dx is equal to v into 2 log x upon x, and all that remains is substitution. So we substitute the value of v on the RHS, and thus we get this term which we label as a third term. We have got dv by dx. Now what do? We substitute equations 2 and 3 in equation 1. So we get dy by dx. So dy by dx was actually du by dx plus dv by dx. So here dy by dx becomes the answer for du by dx, which we got as a second equation, and the answer for dv by dx, which we got as a third equation. Both are substituted, and this is our final answer over here. In the next sum, we have y as the sum of 3 terms, that is 10 raised to x plus 10 raised to x raised to 10 plus 10 raised to 10 raised to x. We realize, by now we have already realized that y can be solved by simplifying it like this, that is, let u is equal to 10 raised to x, v is equal to 10 raised to x raised to 10, and w is equal to 10 raised to 10 raised to x. Thus y becomes u plus v plus w. Differentiating both the sides, we get dy by dx is equal to du by dx plus dv by dx plus dw by dx. Now we find the individual answers for u, v and w upon differentiation. So u is 10 raised to x raised to x. We take logarithm of both the sides and get log u as log 10 raised to x raised to x. You realize that x raised to x is a power, so it can be written as a product of the log, so the RHS becomes x raised to x log 10. Now differentiating both the sides with respect to x, we get LHS as usual, that is 1 upon u du by dx. RHS becomes x raised to x into the derivative of log 10 plus log 10 the derivative of x raised to x. Now observe the first term on the RHS. The first term, derivative of log 10. You remember that derivative of any constant is 0. Log 10 is a constant, of course. So the entire first term becomes 0. Henceforth, we will not be writing the first term in the derivative of u actually. What about the second term? You see that the second term x raised to x, that is the derivative of x raised to x, it is a bit complex actually. We cannot find it directly. So we have to write it as z is equal to x raised to x. As usual, we write log z is equal to x log x. We differentiate both the sides and we get 1 upon z dz by dx is equal to x into the derivative of log x plus log x into the derivative of x. Thus we get the RHS as x upon x, because ddx of log x is 1 upon x. Plus the next term becomes just log x, you know the reason why. Thus we have 1 upon z dz by dx is equal to 1 plus log x. And then dz by dx becomes so. So this becomes our third equation. We substitute equation 3 in equation 2. Thus we get 1 upon u du by dx is equal to log 10 into the differentiation of x raised to x, which becomes x raised to x into 1 plus log x. Thus du by dx is equal to u is written on the RHS and we substitute the value for u. So this becomes our equation 4. Now what about v? V is equal to 10 raised to x raised to 10. So we take log v is equal to log of 10 raised to x raised to 10. Thus we have log v is equal to x raised to 10 into log 10, because we realize that x raised to 10 is the power of the log. Differentiating both the sides with respect to x, we get 1 upon v dv by dx is equal to x raised to 10, the derivative of log 10, plus log 10, the derivative of x raised to 10. Again, the first term on the RHS is 0 because log 10 is a constant, and the second term becomes log 10 into the derivative of x raised to 10. You remember, we use the formula for x raised to n over here. That is n into x raised to n minus 1. So this becomes 10 into x raised to 10 into x raised to 10 minus 1. That is 10 into x raised to 9. Thus 1 upon v dv by dx becomes 10 x raised to 9 log 10. We substitute the value of v on the RHS and we get the answer. This becomes our equation number 5. We also have w as 10 raised to x, 10 raised to x. So log w is equal to log of 10 raised to 10 raised to x. And then log w is equal to 10 raised to x log 10 in the usual manner. Differentiating both the sides with respect to x, we are going to get 1 upon w dw by dx is equal to 10 raised to x derivative of log 10 plus log 10 the derivative of 10 raised to x. Before we go on to the next slide, can you guess what will the first term become? Correct. The first term will become 0 because log 10 is again a constant, you realize, isn't it? The first term is going to be 0. Let us see what the second term becomes. So the second term becomes log 10 into 10 raised to x log 10. So over here the formula used is a raised to x formula. The derivative of a raised to x log a. So the derivative of 10 raised to x, it is 10 raised to x log 10. Thus the term becomes like so. We realize that there are two log 10s terms which are multiplied. So log 10 the whole square into 10 raised to x we get on the RHS. Thus dw by dx becomes w into the whole term, and we substitute the value for w and thus get our sixth equation. Now what remains is substituting the equations 4, 5 and 6 in the equation 1. We get dy by dx is equal to, we substitute equation 4 plus equation 5 plus equation 6 as we got the answers in the previous steps over there. Thus this is our final answer. I hope you understood these sums. If so, you can do these next two sums as assignment in your notebook. Children, don't think that assignments are unimportant because they have been taken from your exercise sums as well as from your miscellaneous exercise sums. So they are going to be important itself. You also read the solved examples which are given in your textbook because quite a few of them are given. Sums can come from there as well. And look at this fifth sum. Again, fifth sum is as usual two terms, complex terms which are added together. You have to find the derivative of these two terms. It is from page 101 of your textbook, which is an activity sum. Now, in that sum, the first few steps, a bit of a printing mistake is there. I will not tell you what the mistake is. Let me see if you can find it out. If you cannot, of course, you can ask me through WhatsApp. But let me see if you have understood the concept. Then you can find out what mistake it is as well. So I leave it up to you as a tricky question. In the next lecture, we meet with the next concept of the lesson. Till then, keep practicing, stay safe and healthy.